Good morning. My name is M. Sheshagiri, working as support staff in this laboratory. So, the main purpose of taking this video, it is very useful to the BWE students, lab students, first year students. So, they have finished first cycle of experiments on few theorems like Thevenin's Norton's theorem, superposition theorem, Ohm's law. So, all the theorems carried out on a voltage of 30 volts AC as well as 30 volts DC. But in the second cycle, whatever the experiments we are going to conduct, so all are on high voltages like 220 volts of DC and 440 up to 440 volts of AC. So before doing those experiments, here I would like to explain about the internal parts of a motor, power supply, generator types, and very useful explanation on the motor description. So when a student in the classroom, when madam is going to explain about the theoretical concepts with the help of some diagrams, those diagrams are not exactly similar to the original components what we are going to see in this laboratory. So those diagrams are all symbolic circuit diagrams. If you see the live part of the motor, whichever drawn on the board, so that will be very useful for a student to understand whatever the theory explained in the classroom. That is the main purpose of this video. So before going to experiment part, we would like to understand about the power supplies what we use in the laboratory. Actually, this is called control panel. So everyone knows that power supply generated somewhere else and sent to very big substations, and from there it is sent to substation, from substations to transformers to houses or some institutions like this. So from the transformer we are getting power supply on the control panel. So basically we will take three-phase voltage. So that is coming at this grid point. So from here main supply, we will switch on the main supply board. So here you can see three lights are glowing, R, Y, B. Generally three-phase voltage represents as with the colors red, yellow, blue. These three are the phases, and one more neutral will be there. So apart from three-phase voltage, we have single-phase voltage. There we will find any of these three phases, any one of these three phases with respect to neutral. The voltage between phase and neutral always 220 volts and 50 hertz frequency. Here you can see this is the frequency meter. At exactly at 50 point the mercury is vibrating. So you can understand that Indian standard frequency is 50 hertz. Hertz is nothing but 50 cycles per second. So in generating station, the alternating cycles, AC voltage will be in this alternating cycle shape. So that type of cycles, within 1 second 50 cycles are produced, generated. So that is called, cycles per second is nothing but frequency. Okay, the standard voltage between phase to neutral will be always 220 volts, 50 hertz frequency. And if you consider the voltage in three-phase voltage system, so any two phases voltage is considered as voltage. So you can see here it is showing 440 volts. This is the voltage in between R and Y phases. So here also it is showing the same voltage, Y and B voltage. If you change the switch, it is the voltage between R and B. Now you can understand that the three-phase voltage system is represented in between any two phases, either RY or YB or RB. So 440 volts and the same frequency, 50 cycles per second. So this is about the system. First we will get three-phase voltage. After that, this section is AC supply from the three-phase system. If you take one phase and one neutral, so that will be single-phase voltage. All three phases are taken, that will be three-phase voltage. All three phases is connected to MCB individually. Here you can see one. So the very first panel in this laboratory is a three-phase motor where the three-phase voltage is required, and that is controlled with a miniature circuit breaker. This is called MCB in shortcut, miniature circuit breaker. So if at all any short circuit occurs over there, it is directly going to strip off. Thus the equipment will be safe. It doesn't allow the short circuit current flow through the equipment, right? So here you have different types of MCBs. So it is TPST, triple pole single throw. It is thrown in single throw and it is having triple pole RYB. So it is used for three phase. And apart from this, you can see DPST, double pole single throw. It is single throw, double pole. One is phase and one is neutral. You can understand DPST is used wherever the single phase motors are erected. There we require the single phase voltage. So apart from this, we have one more that is called SPST, single pole, single throw. Only single pole, single throw. This type of power supplies used for the display meters. These are all the display meters. It requires only phase connection. So that phase is connected to display meters. So that is the purpose we established with these SPSTs. Single pole, single throw. These are the types of MCBs, miniature circuit breakers. And also the purpose of MCBC is whenever unfortunately short circuit occurs, it doesn't allow the excess rated current above rated current range, and immediately it is going to trip off, thus keeping the equipment safe side. That is also the purpose of MCB, right? So this is about AC supply, and if you switch on one panel, the supply is taken from this channel towards one panel. There again we have a control MCB. So after reaching here, if you switch on this, the power is allowed over there, and start buttons are there. If you push this button, that current is connected to the terminals. These are the sections. First section is mains, second section is MCB, third section is control panel MCB, fourth section is through fuse production. It is connected to terminals. From these terminals, the motor is going to connect. So this is about AC. When coming to DC section, we have an equipment backside of this panel that is called rectifier. So this is DC rectifier. Input to this equipment is three-phase AC. It is further going to convert by the appliances of SCR, silicon control rectifier. So this is going to convert that AC three-phase voltage into DC voltage. So the ampere rating of this kit is 100 amperes, and the input voltage we will get, output voltage we will get is 220 volts. That we can see from the voltmeter erected. This is about rectifier. From this, again, main supply is taken to the mains of that DC section, and from that it is distributed to the individual MCBs. From MCBs, it is taken through this channel towards the panel wherever the DC motor is erected. Rectifier, which is going to convert three-phase voltage into DC voltage there. So some DC motors are there in this laboratory. So there we require the input voltage as DC. So from the rectifier, it is connected to the DC mains. After this, if you switch it on, the DC main is connected. You can see 220 volts maximum voltage of DC voltage. Here also all DCs are required, only positive and negative terminals are there for supply terminal. So plus minus is controlled by DPST MCBs, double pole single throw, right? All these DC section are having only DPST. This is about the main panel, and the DC supply also taken to 7th panel means suppose 7 is switched on, and also for display meters you have to switch on single switch. There the seventh panel is connected to the power supply. From there we can operate the voltage. This is about the main panel. So every student can understand that the motors basically divided into two types, depends on the input voltage. So AC motors which will take AC and run are the AC motors. DC motors which will take DC as input and run, those are DC motors. In AC motors we have two types of motors, that is three-phase motors and single-phase motors. Again, three-phase motors are divided. As far as first year syllabus is concerned, we are going to see only one type of three-phase induction motor. There we will discuss about the motor. This is only the description of equipment. So we'll see the internal parts of the three-phase motor later. The motor divides. Basically, a motor is defined as it reduces the human effort. Suppose in our previous days there is a well, one should have to take water from the well with human efforts. Nowadays a motor is erected beside of that well which is going to pull the water through the pump and give us directly. So this is going to reduce the human effort. Like that we have various examples of motors outside world. A tram circuit, train is also running by the motor, and lathe machines. So all mechanical equipments like that. We some of the equipment by taking motor output, mechanical output and running. So that is the purpose of motor. Motor can be defined as electrical energy, because input to the motor is electricity. Electrical energy is converted into mechanical energy. The output of motor is mechanical. So electrical energy is converted into mechanical energy is called a motor. So that basic motor divided depending on the input power supply, AC motors and DC motors. AC motors are again divided into three-phase AC motors, single-phase AC motors. Now DC motors are again there is a classification in the DC motor. Later, after seeing the live parts of the motor, we will discuss about the classification of DC motors. So far as control panel is concerned, this explanation is enough. We will go to the other topic where the motors are erected over there. Dummy motor, working models are there. With open condition of the motors. There we can see the internal parts of the motor, and as well as working principle of the motor also we can easily understand. Thank you.